never-before-seen volcanic magma chamber discovered deep under the Mediterranean near the volcanic island of Santorini. Using a technique to study seismic waves, researchers revealed a previously unknown magma chamber underneath the Colombo submarine volcano. This is by Joanne Wendell of Life Science. The submarine volcano, whose deadly eruption shattered the picturesque Greek island of Santorini nearly 400 years ago, has a growing, never-before-seen magma chamber that could fuel another massive eruption within the next 150 years, according to a new study. Let's remember this thing erupted about 1,600 years ago. Many believe that it could have been what caused the parting of the Red Sea for the Israelites and Moses to cross. Now, about 4 miles or 7 kilometers from Santorini, 1,640 feet or 500 meters under the ocean surface, lies the Colombo volcano. Yes, 4 miles from the volcanic island of Santorini. The Colombo volcano is one of the most active submarine volcanoes in the world. Now let's remember what happened last year in Tonga. Now, so it's one of the most active submarine volcanoes in the world, and according to historical accounts, its last eruption was 1650 AD, killing at least 70 people. A study published October 22nd, 2022, in the journal Geochemistry, Geophysics, Geosystems, revealed that the previously undetected magma chamber growing beneath the Colombo volcano could lead to another eruption, thus endangering residents and tourists on Santorini. Undersea volcanoes are monitored just like their on-land counterparts, but because undersea seismometers are challenging to install, there are fewer of them, which means scientists have less data on undersea volcanoes. In an attempt to overcome this problem, researchers decided to try a different technique to study the inner mechanics of the Colombo volcano. Specifically, they used a method called full waveform inversion, which employs artificially produced seismic waves to create a high-resolution image showing how rigid or soft the underground rock is. Full waveform inversion is similar to the medical ultrasound. Co-authored Michael Paluto, volcanologist at Imperial College London, said, "It uses sound waves to construct an image of the underground structure of a volcano." Seismic waves travel at different speeds through the Earth, depending on the rigidity of the rocks they pass through. For example, a type of seismic wave called a P wave travels more slowly if the rock is more like a liquid, like magma, than it does through hardened rock. By gathering data about the velocity of seismic waves traveling through the ground, researchers can get a sense of where magma is forming. While on board a research cruise sailing near the volcano, the researchers fired an air gun which produced seismic waves in the ground below. Those seismic waves were measured by monitors on the seafloor. And data from the seismic recording showed a significant decrease in velocity under the volcano, indicating the presence of a magma chamber rather than just solid rock. Further, calculations revealed that the magma chamber has been growing at a rate of 141 million cubic feet, that's 4 million cubic meters per year, ever since its eruption in 1650 AD. Okay, 4 million cubic meters a year. The chamber now holds roughly a third of cubic mile, 1.4 cubic kilometers of magma, the team found. And according to a study, first author Kajetan Krapczewski, a geophysicist at Imperial College London, the volume of magma could reach roughly half a cubic mile, 2 cubic kilometers within the next 150 years. That was the estimated amount of magma Colombo ejected nearly 400 years ago. A new study illustrates how important it is to closely monitor undersea volcanoes. Unlike earthquakes, volcanic eruptions can be predicted to some extent, but only if experts have enough data about the movement of magma under the volcano. We need better data on what's actually beneath these volcanoes, Charp-Cusick said in the statement. Continuous monitoring systems would allow us to have a better estimation of when an eruption might occur. With these systems, we would likely know about an eruption a few days before it happens, and people would be able to evacuate and stay safe. For Colombo, an international team of scientists has been working on establishing a seafloor observatory called Santorini Seafloor Volcanic Observatory, SANTORY. Once the observatory is set up and running, scientists and hazard experts will be better equipped to monitor for possible eruptions. And this is by Joanne Wendell on Live Science. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box